it's time for lesson 24, which is 251, 252. You're learning all about surface area. Surface area is taking these 3D objects and basically unfolding them. So if you were to fold something up in a 3D and then you unfold it, what would the net look like? So for this object, this is what the net looks like, okay? And they're just asking, why do true triangles have the same base, right? And what formula would you use, right? How would you find the area? So they're the same because the base is equal, right? This base is this nice like triangular prism, but it has what you need, which is to have rectangles. The base is equal and rectangular. Rectangular. All right, and the formula you would use is the area, which is the triangle base. So 1/2 base times height times length. That would be how you find the area of each triangle. Sorry, base times height. They want area, not volume yet. So just base times height. Okay, and then if you were to do that, actually do that over here, 1/2. They gave you the base, it was 12. The height was 16. And that equaled, and they already showed you that over there, 96. Okay. Do all of the rectangles have equal areas? They don't, because look at these different dimensions. Okay. This one's much longer than this one, which is longer than this one. No. The dimensions of each rectangle are different. They're covering different areas. Okay, so the dimensions are different, the areas are all going to be different. Okay, that's why if you look here, all different lengths. Okay, what is the surface area of the prism? So it's basically asking you, look, we did this entire thing. You just need to add up all your areas to tell us what the surface area is. So in order to find it, I added all the shape areas. Okay, and if you're adding all of the shapes areas right here, you're going to be able to figure out the surface area of the entire thing. So to figure out the surface area of the entire thing, we're going to add all of them. We're going to take all these numbers. So 100, I'm going to do the bigger ones on top, 200, 160, 120, 96 and 96, 12, 6, 7, 8, 9, 9 times 3 is 27, got 4, 5, 6, 672, so 672 square inches, 672. All right, so that's 251. On the back, it's going to be 252. Doorstop is a triangular prism. Label the side lengths of the net. So if I look here, I've got 3.5 right here. That means that I'm going to have 3.5 on both sides here. 3.5, 3.5. I've got 5 here all the way around. That means that I'm going to have 5s around here. They're all touching. Got 4 5s there. Then we've got 12 inches. This 12 is this rectangle right here. So we're going to have 12 and 12. Then we have this is the length. That's super long. It's 13. So the outsides here are going to be 13. And it's going to be 13 here. They're all the same long length. So now it looks like we've labeled everything that we need to. You can figure out that these are 3.5, so I don't want to get too crowded in there. Using the letters in each section, write and solve to find the prism. So if we want to find all of them, we're going to have to do the surface area is, surface area is going to equal A. There's 2 B's. There's 1 C and 1 D. and then now we fill it in. So surface area equals A. So we have to figure out what this is. So this is 1/2. We're going to have to multiply. So we're going to have to do 15 or 5 times 3.5. So 5 times 3.5 equals 17.5. So we've got 17.5 plus, we've got 2 b's. B is 12 times 5 cut in half. Remember, it's a triangle. 12 times 5 equals 60 divided by 2 equals 30. 2 30s. We've got 1 C, which is 12 times 3.5. Be very organized with your work in order to do this. And then we've got 1 D, which is 13 times 3.5. 45.5. Okay, and then we got to add them all together. So 17.5 plus 60 plus, let's add these, 87.5. Let's do 17.5 plus 60 plus 87.5 equals 165. So it's going to be 106. The surface area equals 165 square centimeters. You're working with area again, not volume anymore, so you're going back to square centimeters and not cubed. So we have 165 square centimeters once you add them all up. Okay. Yep. Just drawing an arrow to make it clear I did everything up there. All right, an expression that represents the surface area with length, width, and height. So you're going to have 2 of many of these. So if you have to do the entire thing, usually when you're having to do a rectangular prism, if this was, because this is a triangular prism, if you think of a rectangular prism, much of the sides are parallel. So 2 sides are parallel, right? The long one and then the short ones, they're parallel. So you're going to have 2 of each. So basically you're writing that if you have to do length times width, and you have to do length times height, and you have to do width times height, you're still going to have to multiply everything by 2, okay? There are 2 faces. That's what they're called when it's like on the outside that you're looking at. 2 faces with the same area in each net. Considering a net, because a net is the entire thing unfolded, okay? The height of a rectangular prism is 20 centimeters, okay? 20 centimeters is going to be the height of it. And then it says the surface area is going to be 2,400. So basically, I think they're going to make us use this formula. What are the 2 possible sets of lengths and widths? So if they're asking us to say that the length and width can be chosen, but the length has to be 20, so that's like saying no matter what, the length is 20. So 20 times W plus 20 times H, erase U, plus width times height, which we don't know either of those. All right, so I took this formula, brought it down here. They gave us the 20 for the length, but they haven't given us anything else. So we can say, we basically get to choose to find a set of dimensions that are not equal. So I can use 30 if I would like to. I can use 20. I think I'll use 20. So 2,400 equals 2 times 20 times 20 plus 20 times 20 plus 20 times 20. Trying to make it a little easier on myself here. So if we got, that would be 400 plus 400 plus 400. Okay. Then this would be a 2 on the outside. So if we add 400 plus 400 plus 400, that would be 1,200 times 2. That's equals 2400, which is exactly what we wanted. 2400 equals 2400. Okay, find one set where with the dimensions that are equal in length. Okay, so 20 by 20 is equal. 20 by 20 equal. Now we have to find a set that is not equal. Okay, or 20 by 20 by 20. Remember, it's volume. So if this one's equal, I have to find one that's not equal. That means having the length not be 20, because otherwise it wouldn't work. So I guess we'll do 30. So this would be, we could do length equals 30, width equals 12. So 30 times 12, that would be 360 plus 600 plus 240. All right, when we add all of these up, it's going to be 840. 360 plus 840, that would be 1200, and then we're multiplying that by 2, and it still equals what we need. Okay, so it still equals 2400, but the length and width are not the same. Awesome, that's what we needed. So 30 times 12 times, so length and width, and then height was 20. So length times width times 20. So there's our two. 20 times 20 times 20 and 30 times 12 times 20. Those will be the two that will work for that one. So that's 251 and 252.